Hello, hello, and today I have Poker Doku by Nurider. I've been playing a bit of Balatro lately, so when this puzzle came to my inbox, I was quite intrigued to see what their spin was on poker and Sudoku mixed together. The rules are a little complicated, so I have a bit of a strange setup today, but hopefully it works out okay. We've got, so the rules are Sudoku rules apply with the digits 0 to 9 in rows and regions, but not columns, right? So each row, each region, separated by the bold lines, contains one each of the digits 0 to 9. But in columns, there's no restriction. So, I mean, those are mostly in the same region, but, or I guess there's no place with all four different regions. But if you had, say, here, um, this digit could be the same as this digit and this digit, because they're in different regions. They are in the same column, but that doesn't matter for this puzzle. Cages are normal killer cages. Digits cannot repeat in the cage, even here. And, well, I guess it's 11, so they couldn't repeat. But digits cannot repeat in the cage, and digits in there sum to the total given in the top left corner. We have a non-consecutive rule, so adjacent digits cannot be consecutive. So adjacent means they share an edge. And then I've got four different regions. They're all associated with a different suit, a different card suit. And I have to use these, let's see how many is it, 40 cells to make 8 different hands of 5. And the 8 different hands are a royal flush. So a royal flush is 5, 6, 7, 8, 9, all the same suit. So there'll be some region where 5, 6, 7, 8, and 9 are adjacent, and that can be a hand. There'll be a straight flush. So again, same suit. It will have to be, I think, no, I guess 0 to 4 might work too. So it has to be all in the same suit. It doesn't have to be the same suit as the royal flush, but just some suit where the digits are all consecutive, kind of like a red band, although they can't be 5 to 9. So the last rule here is that each hand is going to count as its highest rated poker hand. So a straight flush that is also a royal flush would be considered a royal flush. It would not be considered a straight flush. So if I had two sets of 5, 6, 7, 8, 9 in different suits, but the same suit within each set, I couldn't count one of them as a straight flush. That's not how that would work. So that is it's a straight flush with four of a kind. So four of the same digit plus some other card that is not the same digit. Full house is a three of a kind and a pair. Flush that's not straight of any kind. A straight that's not a flush. Three of a kind and two pair. And in all of these cases, I'm going to use all 5 cards in the hand, even though there's only 3 that really matter in some sense. Like with the three of a kind, the example is 3 sevens, a 1 and a 4. The 1 and 4 aren't really contributing much to the hand. The three of a kind is just where it's at. But the other two digits are going to tell you something like, well, it's not a full house, it's not 4 of a kind. So they are important in that sense. All right, so let's see. Let's see how we do. Where to start in this? So flushes seem like the obvious place to start. Maybe I should start in these. So I know that's 7 or 9 in the 16 cage. I don't know enough about the 11 cage. I know it's not a 5-6 pair because they would be consecutive. I don't know more than that. Here, I know I need a 0 because if there's no 0, the smallest it could be is 1, 2, 3, and that's 6. So there's definitely a 0. And the other two digits are either 2, 3, or 1, 4. And either way, I get a consecutive set that will need to go in the corners. So for example, if this is 0, 2, 3, 2 and 3 can't get next to each other. So they can't, neither of them can be in the middle here because the other one would be seen. So it's either 0 with 2, 3 on these edge. If it's 0, 1, 4, the 0 and 1 see each other. So they would be on the edge here and have 4 in the middle, sort of. But I don't know more than that, I don't think. So let's think about flushes. This is looking like a really good candidate for a royal flush with the 7-9 pair. But let's think more systematically. I need three of these regions are going to have a flush in it, which is going to take up a lot of their. It's going to take up half of their because there's ten digits in each region. So each flush is going to take up half of the space. And so how is this going to work? I'm wondering if they have to be do they have to be like scrumped to the side or something? I don't know why that would be true, but um, yeah, I don't know how to restrict. Like I'm trying to figure out which one is not going to have the flush, and it's not obvious to me. Like I kind of think this might have to have a flush, because what would it, if not? I would need a flush. Like I would need a flush here and here, something like this, right? I could do something like that as a flush, as three flushes. But then whatever I put here is going to have to be a flush just by construction. Like there's no way for this to get to another region, this cell over here. So, but that's just, I guess that's just the way I did it. What if I did something like this? Yeah, then I guess I could have a couple hands. Um, I have to be careful about how it's, but yeah, it seems like maybe you could do something like this. Although, how, because, yeah, if these two are flushes, maybe I would put it, if these two are flushes, I think this one might have to be a flush as well. No, what if it's all the way over here? So we do this, 1, 2, 3, 4, 5. Um, 1, 2, 3, 4, 5. I can do something like that maybe. And then I could have this as one. That could be a straight, I guess. This, something like that. And then 1, 2, 3, 4, 5. Yeah, okay, I think we could do something like this. Okay, no, that doesn't work. Never mind. So let's think about four of a kind then. It's the other kind of really restricted. So four of a kind actually, yeah, that's very restricted because I need one in each row. And so if I need one in each row, I think I can't have a width of more than two. Or how would I have a width of three? There's no way to have a width of three, right? Even like this. If I have a width of, by width of three, I mean the leftmost digit in the hand and the rightmost digit in the hand take up like a space of three columns. I don't think that's possible because how would that work? I certainly couldn't do them where they're really far apart because then I would need digits to connect them. There's no way I would get that fourth row. And if I did something like this, I think I have the same problem where to connect these, I need to use two cells that aren't either above or below it. I can't do something like this. That's just too big. So I have to connect them directly. And it's something like this or like this or like this. It doesn't matter, but it's a straight connection. Either way, I use two cells and I only have one cell left to get one from each of the other columns. So that doesn't work. And if I have something like this, I can't not connect them. I mean, I could connect them like this, but that's really bad. I definitely am not going to get four rows like that. If I connect them, I have the same problem where two, I have two more cells to get three new rows. That doesn't work. So I can only get a width of two. So it's going to look either like a Y pentomino or an L pentomino, YL. And obviously it could go the other direction as well. Or it's going to look like a N pentomino, I think that's called. I think those are my three choices, L, LY, or N. Um, okay. And now they also have to go in all four regions. So they can't go like way over here, right? So I've got to access this region and this region. So, so to access this region, I can only go this far to the left. And to access this region, I can only go this far to the right because I can only have with the two. So my four of a kind hand is, oops, is somewhere in those 8 cells. Um, and which ones work? I could do I could do an L like the no, it doesn't reach this region. So this has to be in it. Let's call that pink. This is definitely in it because it's the only cell in this region. I need all 4 regions in it. So that's definitely in it. I need one of these. I could have both. Like I could do this Y. That would work. And this digit would be this digit, would be this digit, would be this digit. And that would be the 4 of a kind, and this would be something else. That's one way it could work. Um, this way actually doesn't work because this would have to be the same as this, and they're in the same row. But this works, I think. And then I could have those 4 would all be the same digit, and that would be the extra. And then saying that would also, so those 4 would be the same digit, and that would be the extra. So there's a lot of ways this works. So let's, oh, ah, ooh, no, I was gonna say, but now that I know this, I might be able to go back to flushes and think about flushes for a second. Because I still need 3 flushes, and now I think it is going to be harder to fit those 3 flushes because they can't cross, the flushes can't cross this, um, the flushes can't cross this green section. So how's this going to work? How's this going to work? Where are my three? Where are my 3 flushes? I mean, they're probably just over here, right? And then I have like another region like this or something. Um, like, I mean, I'd be very surprised if this were not a flush. What happens if this is not a flush? Maybe I can prove that's a flush. What happens if this isn't a flush? Then I can't have a flush over here in the region because that would take up both. I need one of these cells to be in the 3 of a kind. Every row needs one of them at least to be in the 3 of a kind. So this can't be the flush. So if this isn't the flush can't cross this. So could this be the flush? I think that, what do we say? This could work. Yeah, this might be able to be the flush. Hmm. That's going to make it harder, I think. I think it's going to make it harder to think through this. Um, but we need the, how do I say this? I think what we need to think about is how to divide each of these sections into 5 cell regions. Because I'm going to take some number of cells away from this green region. There's actually only 5 cars in the 4 of a kind hand. So 3 of these cells are going to get allocated to either the left side or the right side. And we're going to have to do it in a way so that each side is a multiple of 5. So this already is a multiple of 5. This is 20. And this is 12. So I'm gonna so actually, yeah. Oh, then we're just not. It's just like this, right? Because I was gonna say we need to take away 3 of these to give it to the left side so that both sides are multiples of 5, have a multiple of 5. But this one I already know the pink one is definitely in there because it's the only one in the region that works. So it's just this. This is our 4 of a kind, and let's call this A, which is 0 or 4. And I probably should remember it's 0 or 4. But now we can't do this as a flush. So the flush is either here or not. How could it not be there? So let's Hold on, is there more? Can I say whether this is 0 or 4? I'd really love to put a digit here rather than A. If I could, why can't it be 0? Let's say it's 0. This is 2, 3. That eliminates 1 a lot of places. No, I don't see it. What is the reason it can't be 4? If that's 4, this is 0, 1. This now can't be, it could be 3, I guess, or 5 plus. This is 0, 1, that's, no, sorry, this is 1, sorry, no. If this is 0, this is 2, 3. This is 2, 3. So this would be 5 plus. 2, 3. No, I can't remember. Sorry, 4. And we're trying to do 4s now. 4. Sorry, I'm very tired today. 4 is 0, 1. I don't know. Okay. Let's think about something else. Let's think about flushes. So where do the 3 flushes go? It's got to be here, right? What happens if it's not here? If it's not here, then this has to go into, like, these cells have to break into that region. I was gonna say that, but I was gonna say that would mean I couldn't put a flush here, but I think I just barely could. If I do something like this, maybe this, and then this, I could still have 2 flushes there. Oh, it just barely works. It just barely works. I mean, maybe there's even way that it works even more, but I don't see. This has got to be my royal flush, right? 5, 6, 8 over here. What happens if this isn't a flush? If this isn't a flush, then this has to go, this is going to get broken up into 2 different hands at least. I don't think it can be broken up into 3 different hands. Because if I do 1, 2, if I do 1, 2, 3 over here, yeah, because there's 4 hands over here. At least 2 of them have to be a flush. Of the 4 hands over here, at least 2 are a flush. Possibly all 3 are flushes. Sorry, possibly 3 of the 4 are flushes. I can only have at most 1 flush on the left side. So I can't have 3 different hands in, if there's no flush up here, or if there is a flush up here, I can't have, oh, maybe there is a flush, can I? Maybe I could maybe I could do something like this. But if there's no flush up here, I can't have 3 different hands going into this region because well, no, here's an easier way. If this isn't a flush, the other 3 regions that could have flushes, the other 3 regions, there are only 4. The other 3 regions all have to have a flush, which means that's a flush. And 5 of these have to be a flush. Oh no, that still works, doesn't it? Oh no. That does work. Okay. Huh. So what's the way to think about this? Maybe I should think about 3 of a kinds instead. That's surprising. I really thought it'd be flushes. So there are 2 hands that need 3 of a kinds. How do I get 3 of a kinds? Because I can no longer, these 2 regions, like this region can no longer connect to this region. So to get 3 of a kind, I'm either doing these 3 regions like this, not exactly like this, but these 3 regions somehow. Maybe yes, exactly this. Is there any other way to do it over here? How else can I get this region and this region together? If I go from this cell only, if I try to ignore this cell, for example, and go from here down, the only way to do it is to go straight down like that. That cuts off 2 cells. That doesn't work because these need to be part of a hand. So to have three of a kind, it's got to be here. It's got to go to the left. I can't cut up this cell because if I do, I'm making three cells that aren't going to have a full hand. So I've got to go down. I can't do this again. Two cells are going to get cut off. So I have to do this. So yeah, actually over here, there's only one way to get three of a kind. Ah, and that's it. Because now it's actually the opposite of what I thought. This can't be a flush. I thought it was going to have to be a flush, but it can't be a flush because if it is, then these are all taken by the flush. Flush, straight flush, and royal flush. And then how do I get three of a kind over here? I can only get one three of a kind on the left side. So I need at least one three of a kind on the right, which means one of these digits is part of a three of a kind, either the three of a kind or a full house. So that can't be the flush. Wow. So there's no flush here, which means there's a flush here, a flush here, and a flush here, and no flush here. Wow. Okay. How is that going to work? Oh. Huh. But now I can't have this three of a kind either. So before I was thinking I'd have this three of a kind and the flushes over here, but that breaks the other three of a kind. Watch what happens if I try to put a three of a kind here. And now I need a flush over here. How do I do it? This can't be part of the flush. Well, let's just suppose that's a hand. Right? Suppose that's a three of a kind hand. Where does this go? It's got to go here. It's got to take four cells in this region. I don't know which cells they are. Right? Let's call them these cells. But it could be those cells, right? It could be those cells. It doesn't matter. Whatever's left, the point is it can't reach down here. So the third hand that's left over here is going to include some from this region, some from this region. It won't be a flush. So that's not a hand. There's no three of a kind on the left side. So they're both over here. How do I do that? This? No, and hold on. There are four hands over here. Two of them are flushes of some kind, and two of them are three of a kind of some kind. So that's all the hands. So because there's no flush here, all of these cards have to be allocated to the three of a kind hands. The three of a kind directly in the full house. So we'll call this one hand and this the other hand. No, that's too close. So these are two different hands because they can't all be together to be a flush. That would break, as we said before. So they're two different hands. I can't have them be the same hand because then they'd have to connect. This can't be blue because if it did, it could only get one more cell out of its region. So it can't get three of a kind because the three of a kind cards all have to be in different regions because you can't have the same number in the same region. So that's pink. By the same logic, that's blue. That's blue, I think. I don't know what that is. But there's no way this is going to get over here, right? There's just no, this can't connect to this. So this is going to have to connect up here. And it can't take both of these. If it takes both of these, there's not enough to connect. So it's only going to take this one. It's going to be this. That's the only thing that works. Because if I try to do something like this, whoops. If I try to do something like this, we'll cut these hands off. It doesn't give you enough space for a flush. There's so many reasons that doesn't work. So that is one either three of a kind or full house. Oh, and that's the hand. So that's blue. And then the flush, there's a flush here, which there's one cell missing from this flush that belongs to blue. What is it? It belongs to blue, so it's got to be one of those. So these are part of the flush. This has to grow. Got to grow. That's the flush. This has to be a three of a kind now because this can't be a full house because I was going to say those are the three of a kind, but I don't know if that's true. Because it's those two are the same digit. Let's call it B. And then one of these is B. I don't know which one. Could be any of them. And then the other two are different digits because they're in the same region. They're different from B and they're different from each other. So this is the three of a kind. This is the full house. And the full house digits are this digit, which I'm going to call C, which must repeat here, and then one of those spots. And this digit, which I'm going to call D, which must be the other digit in those two spots. And then this is our last flush. Oh, so that's not the royal flush. That's not the royal flush. Okay. Because 7 and 9 are separated here. And the 7 or 9 is here as well. So this is also not the royal flush. This is not, neither of these, the royal flush is over here. The royal flush is on the left side somewhere. Okay. And now this can't be 9 because this, no, is that right? This could be a regular flush. No, that's wrong. Oh, I feel like I'm there. There's something about 9s not being allowed in here. Okay. This is the royal flush. Between these two, the yellow and the peach regions, one is a straight flush, and the other is a non-straight flush. It is a flush that has non-consecutive digits in it. And this digit, which I'm going to call E, E is also in here because E, this is A, this is D, this is C, which are all accounted for. These are all not E specifically. I guess D, the only reason I know D is not E is because this D is 0 to 3 and E is 7 or 9. And same thing with this digit, which I haven't labeled yet. Maybe I'll call it F, but not yet. It's also not E. So E in this region is part of the flush. So the digit E is on a straight flush, either in peach or in yellow. I don't know which one, but E is on a straight flush, and therefore it can't be 9, because if it's 9, that's a royal flush. The only way to make a straight flush for the 9 is 9, 8, 7, 6, 5. That's the royal flush, which we know is over here. So E is actually 7. C is 9. And I can get rid of C and replace it with, oops, 9. Wow. Okay. And now, ooh, I really want to say this is 401. Oh, no, other way. Oh no, how does this work? I was going to say I know what these digits are, but I have no idea what these digits are because I don't know what AD or this is. Okay. One of these is a straight flush. Maybe I can't put a straight in a P. Or maybe I can't put a straight because of this. Hold on. How would this be a straight? It'd either be 7 to 3 or 8 to 4. What would I put here? This digit would have to be, this would have to be one of the extreme digits on the straight, meaning the highest or lowest digit, because anything else, because it sees all three. So like, let's just say this were a 3 to 7 straight. It doesn't matter what it is. And we'll get rid of the 7. Well, no, keep the 7. I want to remember that. Let's say it doesn't matter what the numbers are. We're going to ignore that 7. Just let's say this is a 1, 2, 3, 4, 5 straight. My claim is that this has to be 1 to 5, 1 or 5. Because watch out, if it's a 2, right? If it's a 2, oh no, that does work. 4, wait, hold on. No, yeah. Any other digit that's not at the end is going to have 2 digits that it is consecutive with, right? So if it's 2, it's 1 and 3. If it's 3, it's 2 and 4. If it's 4, it's 3 and 5. And those 2 digits would both have to go here, which doesn't work. So, in fact, if this is the straight, those are the extreme digits because this is one extreme. Oh wait, hold on, is that right? No, that might not be right. No, that's not right. This is one of the extremes. The other extreme can go anywhere. Sorry, that's wrong. But I would know that's an extreme. But that, okay. What does help me? Ooh, maybe I know what A is now. I don't think A can be 4. Yeah, A can't be 4. Yeah, A is not 4. Because A is in neither of these. It's A is not in a straight flush. And if A were 4, the only straight flush that would be possible without it, because everything from 0 to 4 up to 4 to 8, they all take a 4. So the only straight flush that would be possible if A were 4 is 5 to 9, which we know would not be allowed because that would be a royal flush, which is over here, and 9 is taken. So A is in fact 0. We have A. A is 0. And that means these are 2 and 3. Let's keep this as D, and we'll call this C again. These can be C and D. Okay. Okay. And now, ooh, I was gonna say now this can't be a straight flush, but I think it can still. I'm thinking about where does 1 go? Because like one could be B is the problem. So if one had to be in here, that would eliminate this from being a straight flush. But 1 can be B. There's different colors is messing with my region recognition. Oh, but actually the same thing is true over here because 1 can't go next to 0. So, okay, I think that means B is 1. Let me think this through though. Where does 1 go in this region? It can't go over here because of the zeros. It can't be adjacent to a 0 by the non-consecutive rule. So there's two choices. Either 1 is in peach or 1 is B. Same thing with this region. Where is 1? These are just not 1. So 1 is either in yellow or it's B. If 1 is in this region, then it's not B, and therefore it's also in this region, in this flush. But 7, we already decided is in both of these. And 1 to 7 cannot make a straight flush in 5 digits. So if 1 is in one of these regions, it's in both. One of them has to be a straight flush with a 7, so that doesn't work. B is 1. B is 1. And by row logic, it's got to be up there somewhere. Okay. Now do I know where the straight flush? 7, 6, 5, 4, 3. Oh no, I just know what these digits are. What are these digits? 0, 1, 2, 3. This is the flush. This is it. These are 4 to 8, and that's the straight flush. So this one's not a straight flush, which means there's some pressure here as to what those digits can be. They can't be 2 endpoints. So it can't be, for example, 2, 8. It can't be 2, 3, and it can't be 8, 6. Which is, I guess it couldn't be 2, 3 anyway because of the non-consecutive. So it can't be 2, 8, or 8, 6. I'll try to remember that. Okay. But that's not 6 or 8 by non-consecutive. This is not 8 by non-consecutive. Hold on, there's a reason I thought this maybe couldn't be a straight flush before. So because of all this non-consecutive stuff. So maybe I know, here, so what was interesting about the Y is that this was next to almost all the digits. There's only one digit it wasn't next to, so it had to be an endpoint. Is there something like that here? I mean, it's not quite. Now I just have like a lot of digits that all see each other. So if there's a special digit, it's actually the end, which only sees 1. So maybe this has to be the middle or something. Okay, what happens if this is 4? So if this is 4, I get 5, 6, 7, 8 over here. That doesn't work, watch. If this is 4, what happens over here? 5 and 6 are both over here, and they can't be adjacent, so they have to be diagonal from each other. I don't know if it's this diagonal or this diagonal. It doesn't matter. Let's use this diagonal, right? That's 5 and 6. And if you want, you can do that logic the other way. I'm not going to because it's exactly symmetric, but on one diagonal, I have 5 and 6. So the other cells have to be 7 and 8. And the problem with that is that one of these is 6 and one of these is 7. And those are going to be adjacent in some way or another. But wherever 6 is, it can be 6, 7, those are adjacent. 6, 7, that's adjacent. 6, 7, that's adjacent. 6, 7, that's adjacent. Those are the 4 possible ways I could go. So 4 doesn't work. I think I have the same problem with 5, or at least a similar problem. That's 5. And by 4 and 5, it's exactly going to be symmetric again with 8 and 7. With 5, now I have 7 and 8 that need to go in here. They can't be adjacent, so they have to be on a diagonal. Now, where do I put 6? Wherever I put 6, it's going to be next to 7. Either that's 7 or that's 7. So 6 is going to be adjacent to it. So that doesn't work either. The only way this works is if that's 6. And then I'll have 4, 5 on one diagonal and 7, 8 on the other diagonal. The reason I got rid of 7 from here is because if this is 7, that would mean that's 8, and this can't be 8 by this. Same thing over here. That can't be 7. One of these is 8. One of these is 7. I guess 7 also. Oh, and so this can't be 5, so this can't be 4. Okay. We're starting to do something. So this is either 4, 5, or 7, 8. If 4, 5 is this way, I don't know which way it goes. That's probably all I'm going to get here. I really want to keep saying that's 5, but that is not how this works. Okay. So, I don't know. I don't know that I can do more than that. Okay, what are the pairs? So there's a royal flush over here somewhere. It can't take all of these because they would have a 1 in it. The other two are 2 pair and a straight. I'm trying to think what's... Ooh, okay, here's something. These two, so I can't, the only way to connect these regions we talked about before is like this, right? And we said that can't actually exist over here because that's going to break the flush. Because if that's a region, right, this has to grow out, and then it's going to take 2 more cells, it's going to break the royal flush. So what's going to be true is there are 3 hands over here in these 15 cells. One is the royal flush. One, therefore, has to include all of these. I'll call that one, go back to pink. One is going to include both of these. So this pink is going to get another digit up here. This blue is going to get 3 of these, maybe those 3. But that means that the pink region can't be 2 pair. Because I only get 1 cell from this region, and to have 2 pair, I need 2 kind of sets of 2 sets of digits that are both in different regions. So I can't do that. Like what? Let's say it doesn't matter which cell I pick. Let's say that's part of pink. How do I make 2 pair here? Let's say the pairs are 7s and 8s. Again, it really doesn't matter what I pick. I could have, say, 7s like this. I could have an 8, but then where's my second 8? It can't be in the same region as itself. It just doesn't work. So this is not 2 pair. This is a straight. This is 2 pair. And those 2 digits are going to repeat over here. And it's not 1 because all the other ones are taken. 3 of the ones are taken. I can't have 3 of a kind in 2 pair with the same digit. So I need 5 ones for that. So these 2 digits, so this region is going to take the 1 and these 2 digits again, wherever they are, which are not going to be 5, 6, 7, 8, 9, because those are actually part of the royal flush. So these are not 0, not 1. These are from 2, 3, 4. And they can't be 2, 3. So one of them is 4 for sure, not D, 4. I almost said that means C is up here, but that's not true. Okay. I was thinking like D looks in here, but this could be D and this could be 4. But that means 6 and 8 are over here and not here. So 6 and 8. 6, 7, 8. And 5 is over here. Oh, geez. 5 is up here. So, and 5 is not here because that would see 6. So we have 5, 6, 7, 8. 9 can't be there, 4 can't be there. Yeah, okay. Whichever. So now whichever I pick is going to be okay. And so the other digit here is either 2 or 3. I don't know which. Yeah, I don't think I can say more. Can I say something like this? This can't be 6 now because it'll be next to a 5. Uh, this could be 8 or it could be C or D, whatever it is. Yeah, okay. Okay, I think that's all we're going to get there. And now for this straight. So these basically have to be 4 in a row, but there could be one gap that could be filled in with a digit up here. And they can't be consecutive. Oh, that's really interesting. They can't be consecutive next to each other. Actually, this is going to be quite hard to do. And I wonder if that means D has to be 3. Like, what happens if D is 2? Wait, hold on. 9 can't go over here. Well, no, 9's here. Never mind. Can 8 go over here? I think it might. I could have 8, 7, 6, 5, 4 maybe, or something like that. Ooh. Yeah, I think that just barely works. Okay. Let's think about where the flush is. I think that has to be part of the flush, because if it's not, then it's part of blue, which will have to go exactly like that. There's no other way to get there. It has to go directly there in the fastest way possible. But if that's the region, I can't get my 2 pair because this digit will not be able to reappear in the row. So this is part of the flush, which I'm going to call peach. No, yellow, I guess. Misclick, and now it's yellow. Okay, so that's part of the flush. Kind of similar logic here. So all of these cells are either yellow or blue. This one can't be blue because if it is, it's got to go straight there. That's going to cut off the flush from reaching 5. So that's yellow. How about this? If that's blue, can I do this? This would work for the 2 pair, but then this cell has to be yellow. These are all yellow. That breaks. This would have 6 yellows and 4 pinks. Or you could say it can't reach yellow, it can't reach pink. So if this is blue, it can't go this way. So it'd have to connect this way. Maybe I could do that, actually. No, because then if this is the shape, this has to be 1. And then my 2 pair are in here, and this digit can't repeat in its row. So this doesn't work either. So that's yellow, strangely. But I can't say the same thing here because the 1 is going to be paired with whatever this digit is. That's weird. So now I think this has to be blue, right? If this is yellow, because if this is yellow, that's yellow, and the 1's going to be in yellow. So that's blue. And now this has to grow twice. It could go once in here. So this is also blue. So this is yellow. Blue is constrained. You can't get out. So that's blue. So the other blue, so it's one of these two. And the other one, I don't know what the other one is. This could be pink or yellow. If this is blue, I already said this works okay. If this is blue, that's 1. This digit is this digit. This digit is this digit. Which doesn't work because it can't go in this region anymore. If this digit is this digit, so if this is the region, so that's blue. What do I get? That's 1. This digit, whatever it is, call it A, repeats here. This digit, whatever it is, called B, repeats here to get my 2 pair. And then where does B go in this region? Nowhere. It's gone. So blue cannot grow to there. This is blue. And now this can't be pink because that would separate the yellows from each other. So that's yellow. And then something like this. Oh, now this can't be, right? Hold on. What do we say here? The straight flush had to have the middle digit on the little handle here in a p pentamino. So if this is the p pentamino, this is the handle, has to be the middle of a royal flush, which is 7. It doesn't work. So that's yellow, that's pink. And this is a straight, and this is a royal flush. This can't be 5 or 6 because that would be a consecutive 5, 6 in the 11 box. Can't be 9. So this is 7 or 8, and this is 3 or 4. Oh, so now this straight has either a 3 or 4 in it, and of course it does. This is not 0 or 1, so this is 2, 3, or 4, because these are 5, 6, 7, 8, 9 in some order. Neither of these are 7 or 8, so the other digit that's not 7 or 8 goes up here. This is not 7 or, oh, this is probably non-consecutive, same thing. So this has to be 5. It's not 7 or 8, because if it is, this becomes a consecutive 7, 8 pair. It's not 6 or 9, so that's 5. Six is somewhere over here. 9, 7. 9 is over here. 9 is there somewhere. But that tells me at least not I. Let's get off letter tool, which means 8 is not over here. So 8 is either here or here. And that's going to define where the 9 is. So if this is 8, 8, 9. Hold on. If this is 8, this is 9. Now there's nowhere for 7 to go because 7 can't go next to 8 and 7 can go here. So that can't be 8. That's 7. 8 can't go next to a 9. So 8's there, can't go next to 9. So that's 9 and that's 6. That's really cool. That's really cool. This puzzle is so good. I didn't even mention at the beginning, but the Logic Master's Germany rating isn't that, it's like fine. It's not spectacular, but it's a spectacular puzzle. I don't understand. I don't understand what people don't see in this. Okay. These two digits repeat in here, and that's the other one. So then 0 and 1 show up in here. 0 can't go next to 1, so that's, no, 0's done. These are 1, 2, 3, 4. I see. This is 1 and then 4, because 4 has to repeat in here, so that's not 4 actually. And then this is 1, 4, and then the other 2 or 3 digit. So if 2 is the other digit here, 1 and 2 can't go next to each other, so I'd have 2, 4, 1. That's the way. So it would be 2, it would be 2, 4, 1 with 2, 4 like this. If it's 3, 4, and it can't be 3, oh, I've known this forever. It can't be 3, 4 because that's consecutive. That's just what it is. 2, 4, 1, 2, 4. That makes this 3, makes this 4 because it's a straight. Oh, and the 7 makes this a 4. It's so beautiful. This needs a 5 because 0 is taken and 1 is taken actually as well. 5 can't go next to 4, so it's here. 5. This needs 2, 6, or 2, 6, and 7 can be here. It needs a 6 for sure because 1 is taken. So it can't be 1 to 5. It needs a 6, which can't go next to 5. So that's here. This is either 2 or 7. And I don't know which it is. And I think the only way I'll be able to resolve it is to finish these. 3 tells me what C and D are. C is 2, D is 3, which means this is a 3, 9 pair, which means these digits are 1. Let's do in corner marks. 1, 8, and either 2 or 7. I felt like I was finishing up, but now I don't think so. Okay, what are these 3 digits? I should know what these 3 digits are, and therefore this. So these digits are, actually I'll keep those. These digits are 3. 3 is what I need in here. So, wait, what's not here? 8's not here. So this is 8. That is 3. That's 5. That's 6. 5 can't go next to 4, so that's not 5. I still don't know which way that goes. 8 can't go here, so that's 5, 4, 7, 8. 4 can't go next to 3. 9. These ones are really messing with me. What? Okay, 2 or 7. 7 can't go here. 7 can't go here. 2 can't go here. Hold on. How does this work? We're at the very end. It's got to be possible to disambiguate this. These are 1, 8, 2, 7. This is not 7 or 8. This is not 7. It's also not 1 or 2 because that would make a pair. So that's 8. This is not 8 or 7. That's 1 or 2. Can't be 2 because next to the 1. And therefore this is How did we do? We did it. Amazing. Whoops. Great puzzle. Thank you so much for submitting it. Really enjoyed this and hope you liked it. And thanks for watching. See you next time.